Why did I get banned from
Elisa?
You're talking to the wrong guy. You're when you're talking, you're banned from Tinder.
Yeah, I was trying to get
antibodies
on it.
When you're talking, you're banned from Tinder.
I was trying to get
Color changes.
Before I roll the rest of the footage, I would just like to let you all know that I am in fact a high schooler doing this video, A, to increase my grade at a career technical education program, and B, for fun, entertainment, and to test myself on how good I can edit, which is not very good. Believe it or not, I am probably not the most reliable source, although probably better than some random Facebook page. Without further ado, please enjoy, and I hope you learn from this. What's up, guys? It's your boy, Creepy Quagmire 23 here. You're probably watching this video because you've been wondering, probably for years on end, otherwise you're my instructor, who's Elisa? Eliza? Why are scientists talking about her so much? Who will answer to my perpetual dread? Who did we kill? Well, wonder no more. ELISA stands for Eels Love Islamic State Agitprop. Or, alternatively,
Enzyme linked immunosorbacé.
enzyme linked immunosorbacé.
But what exactly does that mean? Well, for introduction, an assay, in broader terms, not essay, an assay assesses the properties of a given object or substance based on observed results of a procedure. Now, ELISA actually happens to have many different uses. It's not just something that's done by a bunch of people in lab coats, but actually, you've probably done some sort of ELISA sometime during your life. For example, COVID tests, which test for the presence of antigens produced by the coronavirus, specifically by certain strands. Pregnancy tests, which test for a hormone that is only produced by pregnant women, and it can test within days of the pregnancy. And drug tests, some drug tests, which actually look for the presence of antigens, antibodies, produced by drugs through their mechanism of action within the body. This might not be the case for many drugs. Some might not be developed but are possible. There's just many different uses, not just limited to these examples. ELISA uses enzymes for this procedure, proteins which catalyze reactions for biological functions. Usually, enzymes which yield visible color changes are employed in ELISA. To my understanding, and yes, this is the type of video that you are watching, to my understanding, immunosorbency is the tendency of a primary antigen or antibody to stick or adsorb to the surfaces of its container, like its walls, whereas the non-desired molecules will be washed out if not bound directly or indirectly to the absorbed primary molecule. And if this is confusing, it was a little bit for me, but I'll try and elaborate a bit here to help you understand, and as well as actually go into the procedure. Now, there are actually multiple different techniques that are employed in ELISA. There are 4 main techniques which are used in the field. That's direct ELISA, indirect ELISA, sandwich method, or competitive ELISA. Although I hear that the sandwich method is the most commonly used, I am going to explain more on indirect ELISA, that is a method that I've actually had some experience with. Now, of course, before you begin the experiment, you should always wear your proper personal protective equipment. That includes a lab coat, some gloves, and of course, safety goggles. You should have a positive and negative control. The positive control should have all of these steps done, and so should the negative, but the positive control will actually have that antigen present. It will be known that that antigen is present in the positive control. In the negative control, you will do the same thing, but you know for a fact that antigen will not be present. The primary and negative controls should be done in triplicate, or that means 3 times each. If any of the positives don't show the change, or the negatives do, then that should be an indicator that your test is unreliable. So the first step in Indirect Elisa is to add a solution of what should contain, or you are testing for, a certain antigen. Add it to a well, and it should adhere to the surface of the well given enough time. You'll then wash out the well so that other products are washed out. However, this may not wash out some other molecules, including other antigens, which are absorbent to the well. This is not much of a problem because we are going to use next a specific primary antibody which should bind to this specific enzyme. You'll add this primary antibody to the solution, and if there are antigens matching the antibody, that primary antibody should bind to the antigens. Wash out again with your buffer and then add in the secondary antibody solution. Now, this secondary antibody should have an enzyme bound to it, which upon the addition of its substrate should produce a color change. Well, some other methods might be used, but most commonly and the best by far would be a color change. Before you add in that substrate, however, again, wash with the buffer, then add the substrate. Now, if that antigen was present, it should have adhered to the wells, and then the primary and then secondary indirectly antibodies should be bound to that antigen and stick with the antigen instead of being washed out. Now, if that antigen isn't present, all of that will be washed out, even if the secondary antibody is attached to the primary antibody. Therefore, after being washed, a color change will not be observed. Now, there are a variety of reasons why you might end up with some erroneous results. For example, if you see that you have one of the positives is not showing color, or one of the negatives is showing color, that is a sign that you've done something wrong sometime during the procedure. Or maybe if all of them are normal, you might end up with a false negative or a false positive, but having a positive and negative control group would make it easier to tell that you didn't. Now, if you did, you might have, say, added in the primary antibody before the antigen. You may have poured in pure hydroiodic acid instead of buffer into your well. Just generally, a control should limit the chance of a false negative or a false positive. However, there may be some false negatives or some false positives depending on what you've done. Having it in triplicate is also a good measure against this.